Beijing shakes the world with loud declarations. The H-20 is a bomber capable of reaching places previously unimaginable, enormous range, tons of internal weapons, and the ability to deliver a strategic strike from afar. But while these words echo from podiums and state graphics, on the other side of the planet, the B-21 Raider, which has already taken to the sky, is undergoing real tests, logging real flight hours, and presenting a real threat that turns speeches into practical consequences. This isn't about who looks better on paper. It's about who can shift the balance of power with a single move. Closed programs, night tests, new logistical routes, hidden bases, and political fault lines that tremble from the sound of one engine. The stakes are not simple air superiority, but the speed at which the world can find itself on the brink of a new, dangerous era. On one side is the B-21 Raider, not just another bomber, but a complete systemic platform, engineered as the next generation of strategic aviation. A flying wing configuration with an integrated wing fuselage design, large internal weapon bays, and engineering solutions that minimize radar and thermal signatures, allowing the platform to penetrate the densest air defenses. According to open estimates, its cruise speed is around Mach 0.8 plus, its service ceiling is about 50,000 feet, and its internal payload capacity is estimated at around 22,000 pounds. In addition, the B-21 is dual-capable, meaning it can carry both conventional and nuclear weapons. The technical architecture emphasizes modern radar-absorbing materials, recessed air intakes, and strict seam alignment, all to reduce RCS compared to previous generations, as well as solutions for lowering the infrared signature. The system's architecture is open and modular. The B-21 is designed with software upgradability and integration of new developments throughout the platform's lifecycle, giving it an advantage in adapting to new threats. On the other side is the H-20, a project aiming to combine long distances, stealthy approach, and significant internal payload. According to open estimates, the H-20's combat radius is measured in thousands of miles, giving it the potential to operate far beyond the South China Sea without constant aerial refueling. Its flying wing shape and smooth body transitions are intended to minimize radar signature. The internal bays are projected to be large. Open sources mention estimates up to 45 tons depending on bay interpretation and configuration, meaning the H-20 may carry long-range cruise missiles, as well as future hypersonic or other high-precision strike weapons. According to available data, the power plant is expected to use Chinese WS-20 turbofan engines, an important step toward independence from imported engines, though their reliability and serial production remain subjects of debate. As for weaponry, long-range cruise missile families, analogous to CJ-20 or CJ-10K, are most often mentioned, with ranges of 1,240 miles for certain variants. Their placement inside the fuselage allows strikes from standoff distances while maintaining stealth advantage. Timeline and cost are major questions. Public estimates place the aircraft's price roughly between $700 million per unit, and the final cost and production tempo will depend on engines, supply chains, and manufacturing choices. Official entry into service is expected closer to the 2030s, but the real schedule remains uncertain. The intrigue is running at full force. The B-21 program is extremely classified. Details about its real RCS, exact engine, and internal layouts remain under top secret. While in September, a second flight test airframe arrived at Edwards AFB, a signal that the project is entering a more active testing phase. At the same time, the H-20 is also progressing in development. Satellite observations indicate activity, but many of Beijing's technical claims remain in question. The practical challenges are real. The B-21 has already faced high costs and difficulties in scaling serial production. If the US cannot rapidly increase numbers, a single technological advantage risks becoming an overly expensive toy rather than a mass instrument of influence. Conversely, if China manages to establish serial H-20 production with acceptable reliability and engines, quantity may become its main currency of power. Imagine two completely different strategies competing for the sky. On one side, the B-21 Raider, an American precision hunter engineered as a brain platform, compact, technological, designed to penetrate dense air defenses, integrate into sensor networks, and deliver selective, high-precision strikes. On the other side, the H-20, a Chinese bomber that thinks on a grand scale, impressive range, large internal weapon bays, and an emphasis on serial production, presence, and pressure through numbers. In lightning-fast encounters where every second matters and victory depends on reaction speed and data quality, the B-21 holds the advantage. It is built to think faster and strike accurately. But in a long campaign, where constant air presence, logistical endurance, and numerous reinforcements matter, the H-20 appears stronger. The key question, therefore, is not which aircraft is better on its own, but which system and doctrine stand behind it. If you have a network of sensors, satellites, and drone swarms, the B-21 becomes a decisive tool. If you can put many aircraft into the sky and sustain them, the H-20 provides constant presence superiority. An important clarification: the H-20 is not yet in service and is not a confirmed operational platform, so many of its stated technical parameters remain estimates or propagandistic claims. In practice, they may turn out to be exaggerated or inaccurate. In contrast, the B-21 has already passed several stages of flight testing, so its potential is partially confirmed by real practice. The conclusion is simple but provocative. The winner will not be the aircraft itself, but the system built around it. This is not just factories and mass production. It is a network of satellites and sensors, drone swarms and communication channels, maintenance procedures and supply chains, crew and operator training, employment doctrines, political will, and alliances ready to support an operation. Technical excellence provides an advantage in individual engagements. Logistics and numbers provide endurance in a long war. And true power emerges when all these elements work as a single mechanism. Whoever can update software and tactics faster, keep the fleet airborne, and maintain operational readiness will turn their aircraft into an effective weapon. So the answer lies not in pure technology, but in the ability to combine technology, people, and processes.